Good morning, students. And today we are going to see some important 2 mark question and answer from the first unit of artificial intelligence. And very soon you are going to face the university examination, and I hope this question and answer will be somewhat helpful to you to face your university examination. The first question is define artificial intelligence, or they may ask what is AI, how can we define it? But the answer will be same for both the questions. Artificial intelligence is the study of how to make the computers do things which at the moment people are better. That is, we are going to create a computer that will be worked in the place of human being. Okay, and artificial intelligence leads four important categories. Four important categories. What are the important categories here? The system that think like humans, a system that act like human, the system like think rationally, the system that act rationally. Okay. So, these four are important categories of artificial intelligence. The next question is define the term agent, agent function, or they may ask define an agent. Agent means artificial agent. Okay. Here the agent is anything, the agent is anything that can be viewed as perceiving its environment. Perceiving its environment, that is, it will be observe the environment through sensors, through sensors, and acting upon the environment through actuators. Okay. So, the agent should have two things importantly, that should have the sensors and actuators. And the next one is agent function. By using these two things, how the agent will function, that is, the agent function is an abstract mathematical description that the agent program is a concrete implementation running on the agent architecture. Okay, this is a simple computer program that will do the actions on the environment. Okay, so this is the very simple diagram of our agent. So this is the agent, this is the agent. Agent is having two things. First one is sensors and second one is actuators. Second one is actuators. So the sensors will observe the environment, that is perspect. Perspect means the current state of the environment, that will be observed by using the sensors, and the agent will do actions on the environment by using the effectors or actuators. So this is called as an artificial agent. And the next question is define ideal rational agent. Ideal rational agent. Okay. So here we are having the same agent. Additionally, we are having knowledge base. The knowledge base contains the historical data or pre-experience of that particular agent. So with the help of this particular knowledge base, the agent will perceive the environment, and that will compare this with the knowledge base. Based on that only the corresponding action will be performed on the environment. That is, for each possible percept sequence, an ideal rational agent should do whatever action is expected to maximize its performance. Maximize its performance measure on the basis of evidence provided by the percept. Evidence provided by the percept sequence, that is, it will continuously observing the environment and whatever built-in knowledge that the agent has. Whatever built-in knowledge means already it is having some knowledge base. So it will compare and the pre-experience with the current state. Based on that, it will do the corresponding action on the environment. So this is called as ideal rational agent. And the next question is, how do you represent problems and nodes? How do you represent problems and nodes? Here we are having state, parent node, action, pathcast and depth. So these 5 things are important to represent the problem. To represent the problem. What are the important things we are having? State, parent node, action, pathcast and depth. Okay. State means the state in the state space. State space is nothing but our environment. Okay. The state in the state space to which the node corresponds, that is the current state of particular environment, that is called as state. Okay. So here we are having initial state, goal state and in between states. So many states will be there. And next one is parent node. Next one is parent node, that is the node in the search tree, the node in the search tree that generates its that generated this node. Okay. So initially the root node is the starting state and this may be the parent node. From the root node it will generate the neighboring nodes. Neighboring nodes like this. Okay, whatever it may be, the nodes will be generated. So for this particular node, this is the parent node. For this particular node, and this is the parent node. Okay. So parent node means from which we are going to generate the neighboring node, that is called as parent node. And next one is action. The action that was applied to the parent node to generate the node. Okay. On what basis we are going to generate the child node? Okay. So that is called as action. So we are going to perform an action on this parent node. Based on that, the next node will get generated. That is called as action. And next one is pathcast. Pathcast. Pathcast means traditionally denoted by G of n. Pathcast is denoted by G of n. The path from initial state to the node. Here our initial state is parent node, that is root node. Root node is our initial state. From the root node, for example, this is our current node, means what is the path cast between parent node and the current node. So this is called as path cast, indicated by parents pointers. Okay. And next one is depth. Depth means the number of steps along the path from the initial state. Okay. That is the number of steps along the path from the initial state. Okay. So this is our initial state and this is our current state. How many steps will be there to reach this current state? So this is called as depth. Okay. So how do you represent problems and nodes? What are the important things is there to represent the problem? Means first one is state, that is number of states, all possible states, and next one is parent node, and next one is action and pathcast, next one is depth. And the next question is how to improve the effectiveness of search based problem solving technique. Okay, search based problem solving techniques. How to improve the effectiveness of search based problem solving techniques. So, to improve the effectiveness of search based problem solving technique, the following 4 components should be defined, then we get the optimal solution. Okay, to get the optimal solution, we have this following 4 important components. First one is initial state. First one is initial state, and next one is what action should be performed, next action, and next one is goal test. After performing this particular action, we need to test whether we reach the goal or not. And next one is what is the path cost. From the initial state to current state, we need to calculate the path cost. So, to reach the goal, the path cost should be minimum. Okay. So, these 4 are important components to get the optimal solution of any particular search based problem solving technique. Okay, what are the things? First one is the initial state that the agent starts in, where we are going to start the particular problem, that is initial state. And next one is description of possible action available to the action. What are the actions will be there? The list of possible actions. And next one is goal test. So, after performing a particular action, we need to test whether we reach the goal state or not. And next one is path cost. Okay, what is the cost of path from the initial state to current state? So, all these things we need to compute carefully to get the optimal solution of particular problem. And next question is give the PEAS, that is piece description of an interactive English tutor system. Interactive English tutor is an agent, artificial agent. So, in that interactive English tutor agent, what are the piece components? Okay. Piece, first we should know what is piece. P means performance, E means environment, A means actuator, and S means sensors. Okay. Piece, performance of this interactive English tutor, maximize the students score on test. We should feed knowledge to the students. So, the performance is we should give the maximum score on the test. And environment, what is the environment of English tutor? A set of students and testing agency. Okay, for these students only we are going to teach the English, and after teaching English we need to test their knowledge. Okay, and next one is activators. Activators are display exercise, suggestions and corrections. So, these are the activators. By using these we are going to test their knowledge by displaying the experience, and we can give the suggestions and corrections. And next one is sensors. Sensors are keyboard entries. Keyboard entries are sensors. So, these are the piece description of interactive English tutor system or interactive English tutor agent, right. And the next question is write the informal description for the general tree search algorithm. Tree search algorithm, that is informal description for tree search algorithm. So, here the tree search is generated by initial state, and the successor function that together define the state space. When the same state can be reached from multiple paths, then this tree is called as search graph. Okay. Here tree means there should not be any loop. Okay. So, this is our initial state. From the initial state we are going to implement this successor function. So after the successor function we will get the next state. We will get the next state. Okay. If we perform all these things repeatedly, and sometimes there is a possible to reach the to get the loop. Okay. We are having the this is the current state, but to reach this current state we are having multiple path. We are having multiple path. Okay. So if we get the multiple path to reach the same state, then this is called as graph. Then this is called as graph. Okay. And next one is search node. Is the root node corresponding to initial state. So all these things are nodes only, but the initial node is, the initial state is root node, root of the tree. The next one is depth first searching algorithm, that is DFS algorithm. It always expands the deepest node in the current fringe of the search tree. And if dead node occurs, backtracking is done to the next immediate previous node for the node to be expanded. So DFS algorithm is, so this is our root node. From the root node we are having more number of nodes. More number of nodes will be there, and this is our goal node. Okay, this is our resultant node. So this is our root node. So from the root node we are going to apply the successor function, we will get this particular node, and from here we are going to apply the successor function, we will reach this particular node and this particular node. So this is the leaf node, that is the dead end node. Once we reach this dead end node, then it will do the backtracking to reach the immediate previous node. So from the immediate previous node we will reach here, and this is not the goal node, then it will reach the immediate previous node, and from here it will reach the immediate previous node. Okay. So once we reach here, then by applying the same successor function we will reach this particular node, and this is our goal node. Okay. So once it reach the goal node, then the searching will get stopped. Okay. What is the advantage of this particular DFS algorithm? If more than one solution exists, or number of levels is higher than DFS, is best, because exploration is done only in the small portion of whole spaces. So once we reach this goal, no need to expand all these particular nodes. Okay. We are not doing anything other than this. Okay. All those nodes are not get expanded, because once we reach the goal, then the searching will get stopped, right? And what is the disadvantage here? Not guaranteed to find a solution. Not guaranteed to find a solution, because suppose if there is any infinity level of nodes, means we cannot go back here. Okay. And sometimes it is possible to get loop also, and once we get the loop, then it will go, it will not be backtracking to reach the previous node. In those situations there is no guarantee to find the solution. This is the very big drawback of DFS algorithm. The next question is, list some metrics to measure the success of an intelligent program, or state on what basis search algorithms are chosen. Okay. So list some metrics, important metrics to measure the success of an intelligent program. To evaluate an algorithm's performance, we have to evaluate the following 4 criterion importantly. 4 criterions are very much important to measure the success of particular intelligent program. First one is completeness. Completeness means the strategy guaranteed to find a solution when there one exists. If there is a solution, then we should be guaranteed to reach the solution, then only the algorithm will called as complete algorithm. And second one is optimality, that is, if more than one solution exists, then the algorithm should give the best one. Okay, so for example, this is our search space tree and this is our goal. This is our goal state. This is initial state. So from the initial state, we are having more number of possible paths to reach this goal state. But our algorithm should give the optimal path. Okay. So this is the best path. This is the best path to reach from initial state to goal state. So this is called as optimality. And next one is time complexity. Time complexity means time taken to run a solution. The algorithm should take minimum time to reach this goal state. And the next important one is space complexity, the memory needed to perform the search. Our algorithm, the best algorithm should take minimum memory to give the solution. So these are the 4 important metrics to measure the intelligent program, success of intelligent program. What are the things? First one is completeness, next one is optimality, and third one is time complexity, and fourth one is space complexity. Okay. And thank you all of you. And the next set of 2 more question and answer I will give you in the next video. Okay. All the best for your university examinations. Thank you all of you.